All right, looks like we are live. So Istio in Action book was officially out last week. And very impressively, I was just looking at the statistic. Just last week alone, we had like over 2,000 views. Should you add this book to your reading list? Today, we are going to discuss some of the contents of the book so you could make an informative decision. Welcome to the Hoot live stream, where we bring Istio, Envoy, Kubernetes, eBPF, and GraphQL technologies to you so you can be very well prepared at your job and be the best cloud native developers, operators, and architects. My name is Lin Song. I'm the host for the Hoot live stream today, and I am so excited to have Christian and Reno join me today. Reno and Christian, can you guys introduce yourself? Christian, go ahead.
Sure, yeah. Hey, it's good to meet you all. Thanks for joining. I'm Christian Posta, the Global Field CTO here at Solo, and I've been working with Istio for a long time, service meshes in general. I think I met Matt Klein in January 2017. And from there, got involved with Istio and others. So yeah, I'm super excited to talk about the book. I'm super excited to have finished writing the book, and Renor was a big, huge contributor and help to that. So I'll let him introduce himself here.
Yeah, thanks, Tristan. So hi, everybody. And so welcome and thanks for joining. I'm Renor Malioko. I'm a field engineer here at Solo. Previously, I worked as a platform engineer over at Red Hat, and we were implementing a lot of these features. Most likely, I was one of the first people to read all the posts from Christian Posta about Istio, and I was getting excited. So I have some sample applications that I always use. I wrote a blog post. It went sort of viral when comparing just Istio. The community is still not the largest, so yeah. And yeah, it was a joy to join Christian, work on the book, and provide some of my capabilities, which are just going way low into the details and then going back up to not overwhelm people with it. So I hope that that can be seen as well in the book. So back to you.
Awesome. That's awesome. I am really excited to have both of you. So first of all, let's dive into the news. First of all, it's the book, right? I'm going to give you guys, this is new. I'm learning with StreamYard. So congratulations. I am really happy for you guys. And
Awesome.
second of all, the news I would want to mention is you guys, some of you attended over Hoot last week, one-click upgrade to Istio 113 using Helm and Helm file. I've actually published the steps on GitHub, so please follow along with us on YouTube and also on our GitHub. So the steps are here on, episode 20. So that's the second news. The third news I want to quickly mention is IstioCon is coming. So if you want to be getting a t-shirt from IstioCon, register today so you can be the first 400 participants.
It's a virtual conference, right?
Yes, it's virtual conference. It's totally free, and it's April 25th to 29th. Mm-hmm. So get registered if you haven't. The other news I want to share is support for Istio 1.11 is going to end, I guess, in 3 days on this Friday. So if you're on Istio 1.11, so look out for upgrade or maybe partner one of the vendors like Solo to support you on older version of Istio if you need to. Last but not least, Christian sent this wonderful post to welcome Greg Hanson to join Solo. For those of you in the Istio community for a very long time, Greg has been one of the founding maintainers on Istio and also on the Amalgamate project at IBM. So we are so excited to have Greg join us, continue working on Istio. So that's the news for this week. All right, let's get to back to the book. So who is the book for? Can you guys share that information?
Yeah, you know, we've been working on this book for quite a while now. For the people who are interested in modernizing their application architectures using microservices, using cloud technologies, containers, Kubernetes, and so on. It's for those people, but specifically those that are, you know, on their journey far enough where they start to see the problems that Service Mesh solves. Right, they're starting to automate their deployments. They're starting to deploy into containers and Kubernetes. And these are not just very simple web apps. These are, you know, enterprise applications. They're communicating with each other. The enterprise needs to specify the policies about how resilience should behave, how telemetry should be collected, and security should be enforced, and make changes to the system as it continues to evolve. And people like the developers are absolutely involved, architects, platform owners, DevSecOps folks. You know, those are very likely very interested in solving this problem in a scalable way, and are likely the ones leading evaluations and figuring out what are the right ways to solve the problem. So we've written this book for those folks.
Awesome. Anything you want to add, Reno?
Oh, that's really difficult to add on top of that. So what I could say is that if you are new to Kubernetes, it could be probably a little too advanced. You have to know Kubernetes, and for that there are better places to get started. But as soon as you know Kubernetes and you can understand how traffic is going from one service to another, then you are really on a spot to get started with service meshes. But this is from the perspective of learning. From the perspective of business, yeah, Christian covered that already.
That's awesome. So now my next question is, we have a few Istio books out there, right? Even myself, I wrote a very, I guess, a very short Istio book. So what's so special about your book from your perspective, Christian and Reno?
I'll just go first real quick. So I wrote a book back in 2018 on Istio as well. But I guess the most obvious thing is that this one's more up to date. This is actually it went to print with Istio 1.13, which is the most current release, which is pretty awesome, because usually technology books, they become first of all outdated pretty quickly, and behind a few versions, which will probably happen because Istio is going to continue to release every quarter. But we released the book with the most latest version. I would say that another big difference is some of the other Istio books. They do a good job talking about Istio's features, you know, at a level that people can, because when people were looking at those other Istio books, it was mostly like, all right, what can someone give me a Cliff Notes version of what is Istio, right? We don't take a Cliff Notes approach here. This is, 480 pages of 3.5 years or longer of, knowledge that we've been cultivating, building, and evolving, because the Istio community and project has evolved in this time as well, significantly. But I believe it's at a point where it's mature, it's stable, it's hardened, certainly in many areas, and so I don't expect to see the API churn and stuff that we saw in previous versions. So from that perspective, it should stay relatively up to date. And then, like I said, we go into quite some depth to not just what are the features, but when is this useful, and what are some trade-offs? And when you do go down this path, what are things that we've seen that you should keep in mind? So there's a lot of a lot of experience in the book as well. I don't know, Raynor, if you have additional comments.
So when you use Istio, quite often a lot of things look like magic, and a lot of books really leave it at that. So we really go behind the scenes and say, okay, now when you executed this is what happened. Even going low level to the Envoy configuration that is applied. There's an entire chapter just about Envoy and how it is configured and what the control plane does, how it configures it. So just going to this amount of detail that now when you know about how Istio works, if something is not working, you can immediately dive deep into and find out what's the issue. So there's an entire chapter about how to debug the data plane, and one which we will demo today is how to improve the performance of the control plane. Even now, when I'm working with the clients and there is one issue here or there, I will open the book because it's easier to go and find that section and just work with the client and improve it, then start to research it again. So yeah, that's one of the things that I think it makes the biggest difference with the other books out there.
Yeah, I think I'm totally impressed with the breadth and also the depth of the book. It really covers like the first chapter, really covers like the beginner, which I think it's kind of what my book is trying to achieve, right? It's get people started with service mesh. But this book is still in action. It covers like intermediate and also advanced topic, right? So that's made it really interesting, regardless of, where you are on your service mesh journey, you can probably find something really useful for you. And the other thing is like my book was written, I think on Istio 1.3. Now that I'm thinking it's about 2 years old, right? So technology does move fast. Totally, yeah.
It moves fast, but like I said, if you look at Istio 1.0 and then the releases up until 1.5, there was a lot of learning and some course correction and so on based on that learning. And once we got to, I feel, Istio 1.6, and then all of the releases after that, it's almost like we converged, and then we started to mature, and that's obviously a foundation for why Istio is so successful today, but also hopefully enable some longevity in the book here, and then we'll be working on a second edition, I'm sure. So we'll keep up to date with what's happening on Istio anyway.
Yeah, totally. So I guess one thing that puzzles me most is, both of you have your full-time job, and this book sounds like it's been like 3 and 4 year time and effort. So how did you balance like writing the book along with your full-time job? Is it like a lot of weekend projects for you?
I'll let Raynor go first.
Oh yeah, so probably around 6 months, I never took off one weekend to do some other stuff. It was all going into the book. Just because I'm not so effective and I work just 1 hour or 2 hours, I was not able to do the approach where split every day 1 hour or so. I just had to have like 12 hours of just working on the book. That's why most of the weekends had to go there. Yeah, and I think that's it, what it took for me. So to you, Christian.
Yeah, let's be honest. 3.5 years of the book, taking to write the book, wasn't because we were writing every single minute. There was definitely, I started writing, I believe, in August or July 2018, before Istio, right as Istio was becoming 1.0, and then at the end of 2018, I joined Solo. And, Solo, we were, 9-10 people back then. And basically starting from the beginning. We're building the company, and so that took a significant amount of time. And so there were breaks, definitely, pauses, let's say, some long pauses. And but while we were working on Solo, we're also paying attention to what's happening in the Istio community, and things were churning, and there were some hiccups, and so a lot of it ended up being the timing and how everything happened. It worked out. It couldn't have worked out better. But there was definitely some, and halfway through I realized I don't have unlimited, and I can't make more hours in the day. So Renor joined I don't know, Renor, what was it, halfway through?
Almost 2 years. Yeah, almost 2 years ago.
Yeah. And that provides, so that maybe it took a long time, wake up early, work on weekends. I mean, just you figure it out. But I think at the end of the day, especially if there's other folks out there that might be interested in writing a book, what I could say is working with another person and another author, that brings a motivation that is difficult to sustain when you're working by yourself. Now, can you do it of course you could do it by yourself, but like having a second person and feeding off of each other. And Renor did some work, and I said, shit, I can't sleep in. Renor's out there working, so I gotta get up. That having a co-author to get you through the I think I wrote the first 4 chapters in like 2 months, right? And then I took pause, rewrote, did all this stuff, and then got dragged into building the startup and so on, and distracted and everything. But if you have somebody else working with you, that will give you a lot of motivation to stay the course and finish the job. So definitely huge thank you, Renor. You helped in ways that you may not even know, but for people watching, definitely having a co-author is very valuable.
Yeah, and for me, it was an absolute pleasure to work with Christian. He laid so much trust into me. I was not really expecting that, because usually when you start to add, you have your own like baby, you really care about everything. Just handing off trust, that's really difficult. But in my case, it was like I was writing a chapter, meeting like through the first draft with Christian, reviewing it, and then progressing on it, taking some feedback, improving it further. So it ended up like being a really nice cycle. And when you get to a book which is 450 pages and your editor sends his review back, you have to go through 450 pages. Man, that's such a downer. Having 2 people to share, like to split the weight, that's so good.
Yes, absolutely.
Yeah. All the memory of me, going through my book and working with my editor, even I think it's just on 70, 80 pages of book, is that 10 times, right? With the length of your book. I can't imagine. So good job. And Renor, I think you are the first, this is your first book, right? So huge congrats.
Yeah, absolutely. Yeah, thank you very much.
Yeah.
So besides, if you do a second edition, this most likely will be my last one. I love writing articles that are probably 30 pages, but writing a book, that's another thing.
Yeah, that's what I said to myself. This might be my last book too. Okay, so we have our first question comes up now, which is very exciting. So thank you for that question. I'm not sure if I can pronounce your name, Harinda. Istio is the foundation in Ansel's OpenShift Service Mesh and also Glue Edge. Is there any competitive comparison between these solution offerings?
Yeah, there is. And I can give you the quick, the too long didn't read, version. So Istio is, like I said, extremely popular service mesh. We've seen massive deployment. We at Solo are working with some of the largest deployments of service mesh in the world, and what you'll see is Anthos, which is a Kubernetes and cloud platform. You'll see OpenShift with the Kubernetes cloud platform, and what we do here at Solo is actually, and it's actually Solo Glue Mesh. But what we do here at Solo is we focus on just the connectivity pieces. We don't care what Kubernetes you end up using. And so from a feature standpoint, there's a long list. Go to solo.io, go to the Glue Mesh. I'm not going to go into that right now, but the others, like Anthos Service Mesh, for example, is a rebranded version of Istio, right? That integrates with some of the Google Cloud pieces. OpenShift Service Mesh is a forked version of Istio that builds on top of OpenShift primitives and is very OpenShift centric. It deploys only to OpenShift. Glue Mesh here at Solo is we're built on upstream Istio. We have long-term Istio support and all that stuff too. But we built a lot of the pieces that enterprises struggle with when they adopt a service mesh, like, for example, multi-tenancy. So having a nice Kubernetes native API for tenancy and multi-cluster configurations is a huge, is a very important feature. Bringing the Glue Edge Gateway to Istio and building the API gateway directly on top of Istio. Having unified dashboards and observability across your deployment, might be multi-cluster, multi-cloud, all of these things. eBPF, we've brought eBPF to the service mesh, GraphQL. So we see this Istio as a piece of the puzzle, but we've built a lot of application networking components around it. And I'll even put into the chat here, Lynn. I'm not sure. I'll put it in here. How do I put it in here? But maybe we will we'll link to it. But here, I'll put it in the private chat.
You can send to me. Yeah.
I'll put it in the private chat, or I'll put it on our Slack. But yeah, this link, this blog post goes into a lot more detail about how we stack up against some of the other vendors.
Yeah, so this is the blog Christian just mentioned. We just shared in the chat. So feel free to read a lot on your own. So thank you for that link, Christian.
Yeah.
All right. Thanks for the question. So again, if you guys have any questions, just send to us, and let's continue our book discussion. What are the favorite parts of the book for you guys?
Oh, favorite part.
Yeah, which chapter or what's your favorite moments?
I think mine is going to be chapter 6. And chapter 6, if I remember the ordering of the chapter, because we've changed the chapters around also throughout the time here. But let me just go make sure. So it's the chapter on resilience. That is.
Yes, it is resilience, solving application networking challenges.
Yes, that one. Yeah. And that one's my favorite because that is one of the first group of features that got me really interested in the service mesh, in Envoy proxy, actually to be specific, because at the talk that where I met Matt Klein at I think it was some conference in San Francisco. Hey, I was already looking at Linkerd, the old Linkerd, and I'd come from building these types of tools and frameworks and stuff for Java developers in the past anyway. And what I was looking for was something very lightweight and that had a full set of features for controlling how requests behave on the network, especially when things start to fail. And I remember watching Matt's presentation and seeing all these things about controlling the traffic and traffic mirroring and circuit breaking and retries, this type of stuff, and thinking, oh wow, this is, and it's written in C++, it's extremely performant, and it's already running at Lyft at this time, so it's a proven thing. And that was my initial, okay, for developers, this is a pretty important, piece of technology, because as developers, we were writing this kind of stuff into our code. I remember Netflix OSS and bringing in a library called Hystrix, a library called Ribbon, and just a bunch of other stuff. And I remember others were saying, well, you just have to have really strong developers and they have to understand this stuff in and out. And I was thinking, of course, we want good developers, but I want the developers working on business problems, how things interact on the network. Something else should be able to do that and do it very efficiently and effectively. So that's where I got started with the service mesh and getting into Istio, timeouts, retry, circuit breaking. Those were all, and actually the initial blogs that I did around Envoy and Istio were on those topics. And in chapter 6, we talk about load balancing. We talk about locality aware load balancing. Talk about retrying and budgets and circuit breaking and all of those concepts.
That's awesome. What about you, Rina?
Yeah, just that's why the 6th chapter is one of the longest, and even later on, Christian cleaned it up, made it shorter, and still it's one of the longest.
That's true. Yeah.
So I really like chapter 4, which is Istio Gateway, getting traffic into your cluster. It covers so much, like how to secure traffic, how to get it to the workloads. It already has some information of how to make the traffic be encrypted, MTLS, and it sets like really the groundwork. If somebody gets started and he's really just wanting to know how he can use Istio and gain the benefit out of the box, he should just get up to this chapter. Anything after that, it is like going a little more advanced, like intermediate, and then the advanced chapters. The nice thing about this chapter is as well that it gives you so much information that it makes all the other chapters to be way more detailed. Otherwise, it would be like a repetition of the same. So that's why I really like this chapter. And then it's the chapters about troubleshooting the data plane, performance tuning, scaling Istio in your organization. So the reason why I like these chapters is that I wrote them. No. So the reason why I like these chapters is that these really go into the detail of like not really letting you into a place where you deploy stuff and you are not sure how things are working. At this part, you really need you learn everything when something is not working, how to debug it, how to make it work across clusters. If the traffic is not going successfully to the other side, how you can find out where it is failing. And as a platform engineer that I worked as 2 years, deploying a service, for example, like Istio is quite easy, but troubleshooting it and helping all your clients, all your customers on the platform, that's another field, another area that is of major importance. And that's why these chapters are just probably a little more towards platform engineering teams and as well architects that want to scale the mesh into multiple clusters.
So it's more intermediate and into advanced.
Exactly. This is bordering to the advanced area.
Yeah. Okay, we have our second question coming in now from Raphael. Hey guys, is Istio in Action going to be available on O'Reilly platform? And do you see do you see Envoy being removed from Istio? I've seen some article on how Istio can work on its own proxy, I'd assume, or something. I guess it's kind of cut off now. Do you guys know the answer for the O'Reilly?
So for the O'Reilly platform, I'm not sure. I know O'Reilly obviously has all of their books on the O'Reilly platform. I do believe they have other publisher books on the platform as well. If you can get other Manning books on the O'Reilly platform, like Kubernetes in Action or Microservices in Action. If you can get those books on the O'Reilly platform, then I would imagine that Istio in Action would eventually get to the O'Reilly platform as well. Now, do we see Envoy being removed from Istio? Just to, I don't know the level of folks who are joining the live stream here, but Envoy is what makes Istio what Istio is today. And so Envoy is the data plane proxy in the Istio service mesh, and has been from the very beginning. And so now the question is, do we see it being removed, or Istio working on its own? So the data plane of a service mesh is a really interesting area of technology and evolution/innovation. And I don't know, maybe we can put another blog post in here, but
Is that the eBPF one?
Yeah.
I'll try to find it.
Okay. So basically, actually, I did a talk about this at Service Mesh Con 2019, which was that the data plane for a service mesh is a spectrum of what the implementation looks like. Right. So let me see, eBPF. And so Envoy today is and actually more specifically, the sidecar. Here, Lynn, I'll DM it.
Sorry, it's a little bit hard to navigate. I think I got it though.
I sent you the link. So
the future of service mesh, this one.
That also, yeah, from SoloCon. That's a great. Actually, that's a good one for sure. Send that one and the link to the blog. But the more interesting question is, Envoy being deployed. Where is Envoy deployed, and how is it deployed? Or maybe, in highly optimized scenarios, maybe removing Envoy completely. So sidecar is the model that is deployed today, typically. But as you know, Istio has gateways, which are not sidecars. And there are, shared proxy models that are evolving, and that we're leading the effort on in our engineering team. And you'll start to see more of that come out pretty soon, I would say. But yeah, there's definitely an evolution coming. Envoy is the foundation, though. I would be I don't want to leave the impression that Envoy is going to be replaced with something or something like that. But there will be more efficient deployment options and optimizations that we can make for the proxy, which improve, based on the various trade-offs you're willing to make. Now, there's also the proxyless option, which I would say is a very highly optimized use case, where you might want to use the gRPC libraries for load balancing. There's all this stuff. Yeah, you can see the proxyless. But like I said, that's an optimization. A big part of using the service mesh is so that you don't have to embed a lot of this stuff into your application code, because that gets difficult with all the different languages you might want to support and frameworks and so on. But the data plane for a service mesh is a continuum, and you're going to start to see a lot more optimizations that are available for it.
Yeah, I think that's a good reply. I don't see Istio upstream, would change the default data plane proxy at all. I know when the project was very early I think it was in 2017, somebody from the Nginx team actually did a prototype using Nginx as the sidecar proxy for Istio, and it was successful. But I don't see the Istio project itself would endorse that as a standard data plane. All right, we have a user, Christian, also Christian, wow, said, can't wait for Envoy in Action book. All right, and we have feedback from Raphael. That's what I thought about the Proxylus design. I've seen some work around gRPC optimization on Proxylus deployment. That's awesome. Thank you. Okay, with that, I guess I'd like to kind of dive into chapter 11 because I'm very impressed with that book. So when I read that book, I have a few questions. Like I thought the concept of phantom workload and its impact was interesting. The four golden principle, the four golden signals of control plane, that was interesting. And also the techniques to improve Istio control plane performance. That was interesting. And the thoughts on whether you should scale out or scale up, and of the control plane. Also, should you leverage auto scaling of the Istio control plane? I know this is a little bit more advanced topic, but it shows the depth of the book. So
Yeah,
Reno, I know you have.
Reno is going to drive, but let me just reiterate that part.
Yeah.
That if you came here to the live stream and you're a beginner to Istio, keep in mind that Istio is extremely powerful, and there's a lot of user design, user experience that went into making it as simple as it needs to be for the simple use cases. But what you're going to see here now is an advanced day 2 type scenario. So this is definitely, it's not for beginners, and so you're going to see kind of the internal workings of the control plane and how to optimize and tune for, like what Lynn said, the various scenarios of scaling. All right, so I don't want you to come away from, oh man, this is the thing. I have to understand what to be able to use it. No. This is on purpose. We're showing you a little bit more, one of the more advanced sections, but just keep that in mind.
Yeah, thanks for that clarification. The floor is yours, Reno.
Okay, so thanks. And whenever I probably am too fast or so, just Christian and Lynn interrupt me, extend any of those, elaborate more. So let's initially cover why is it important? Why is control plane performance important? So this is one of those cases that Lynn mentioned out, which is what is the phantom workload? So this is a phenomenon that we saw quite often happening when the synchronization, the time until the data plane is updated, is slow. So here is one concrete example. Here we have two services, where one service with two instances, and when one goes down or is otherwise failing the health check, Kubelet will report to Kubernetes API server that it is failing the health check. And then in Kubernetes API server, there are multiple controllers. One of those is the service controller. It will remove this endpoint from the service because it's not ready to receive traffic. And this is something which is very important for Istio-D. Now, Istio-D will receive this event, and then it will generate endpoint configuration and update the data plane with it, as we see the Ingress gateway, which is way over in the left side. But until this cycle happens, the Ingress gateway will still route traffic to the application which is not healthy, and then requests will fail. This is not immediately visible to the end users because the Ingress gateway, as well as the other service proxies, are configured to retry. But if it continues for a longer period of time, then it will as well leak to the end users. That's why having a performant control plane is actually very important. So let's go to the next part. What are the steps? So basically when we see this, here is Istio-D, but within Istio-D, there are a lot of steps that happen. So now let's zoom into Istio-D. So in this case, we have one incoming event, which is coming from the Kubernetes API server to the discovery server. The event can be a user applying a configuration, or it can be a pod being rescheduled, being killed, becoming unhealthy. So all of these generate events, and those events go to the discovery server, which is a component of Istio-D. The discovery server is quite intelligent. It doesn't immediately push the change to the workloads. That wouldn't be very performant. What it does is it debounces and waits for more events, because when an event occurs, usually there are immediately subsequent events. In the case when you deploy a Kubernetes service and the deployment, so initially the service is an event on itself. The pods becoming ready are other events. So instead of pushing each of those changes separately, the discovery server debounces the change, waits a little further, gets all these events, merges those into one single push requests, and adds those to the push queue. And then it is some workers that are throttled to not exhaust the CPU, where it ends up switching between one task to another. So basically it is throttled, and tasks are picked from the queue one by one and then pushed according to how much you throttle them and pushed to the workloads. So here we see two things, the debouncing and throttling, which are used by Istio-D to improve the performance. So all of these steps have to occur for one change that comes to the Kubernetes API server to go up to the workloads. So next, let's see all the factors that determine the performance. The first factor is the rate of changes. When there are many changes, this will overwhelm Istio-D, especially if these are continuous and there is no space in which Istio-D can generate a configuration and push it. There is a maximum period that after it is, so after the change is debounced and debounced, if this maximum period is reached, then whatever change we have is pushed to the workloads, just to ensure that the workloads are not stale for too long. So basically, rate of changes, that's the first factor. And then it's the amount of allocated resources to Istio-D. If Istio-D has more resources, then understandably, it will be faster at generating all the Envoy configuration and pushing it to the workloads. And then it's as well configuration size. By default, Istio sends all the configuration on how to reach every other service in the cluster. And that's a lot. That's even for the sample that we will see later, that's quite a lot. You can improve this by specifying which configuration is important for which workload. And in such a way, that the configuration which is sent to the workloads will become smaller. And finally, it is the workload count. If you have more workloads, more work has to be done to push all the changes to all the workloads. So next, let's go into the knobs of improving performance. After learning all the factors, we can very easily discover what are the ways that we can improve those. If you have a lot of events, the first thing that you can do is ignore some events. When you install Istio in a cluster, you can specify namespaces or labels on those namespaces that you can ignore. Events on those namespaces won't pick up and push to the workloads. So that the best way to improve performance is to ignore events which are not really important. And then the other option is, let's say we have still a lot of events, but all of these are important. The option we have is just specifying the debounce period and then batching all of those into fewer push requests and then just working on fewer pushes instead of doing a lot of pushes. Finally, when we specify the configuration which is important for a workload, we do that by using a sidecar resource, which we will see in the demo. When you specify those, Istio-D can discern which configuration is important for which workload. And in such a way, it can decide to send the Envoy configuration to the first workload, not to the second, and send it to the third as well. In such a way, not sending it to one workload is already improving the performance. And the final part is just scaling out and scaling up, which is understandable. So now we can switch over to the demo. But maybe I was too fast. Linsun, Christian, do you want to elaborate on any of the points, or yeah, let's go to the demo?
I think the point is, I mean, I know you did great, but Istio's control plane is a tunable, event-driven system that you'll have to explore and understand your environment, understand which knobs need to be tuned. But understanding the pieces and how it works is extremely important to be able to.
Okay, then Lynn, we are ready to switch over to the editor.
Yes, let me do that. We have a couple of questions coming in, but let's see the
Okay.
demo first, because I think the demo is probably very interesting. Then we'll get to the questions.
Yeah. Good. So I have a cluster here, and I have installed into it. So basically, it's based on kind crate cluster. You can use any other distribution. I have installed Istio with a demo profile, and I have applied the Prometheus and Grafana because I want to show some of the measurements when we improve the performance. Next, what we are going to do is we are going to apply a lot of services. So in my site, this will be really fast because I have already deployed those. So let's check this. So the images don't really need to be pulled, and as such, it will be really fast. So most of these are already running. What is here? We have a lot of sleep services, which are just dummy workloads that have the sidecar, meaning that we need to push updates to those. It's just so that we have a little more work for Istio-D. And we have Catalog, which is the service which we can send traffic and make sure that after we create some configuration to route traffic to Catalog, that it is picked up by Istio-D and pushed to the Istio Ingress Gateway. So these are currently what we have running in the cluster. Let's create another namespace, which will later on we will ignore. So that will give us a use case to show some of the capabilities to ignore stuff. So now we are applying 600 resources into the cluster. And this example is taken from the book. In the book, there are explanations about all the steps. So with 600 resources, where we have 3 of each, so one gateway, one service, and the virtual service, and 200 of those, that makes 600 resources. All of those will generate Envoy configuration and push it to the workloads. And so we increase a little further the load that we have on this instance. So before we go to the first part of ignoring the events, let's port forward this to the environment. So I will port forward Istio Ingress Gateway so that when we execute some performance tests, we can reach the workloads. And then let's start the dashboard for Grafana. Let's push this to the left side and then the code to the right side. So now in Grafana, I usually modify a little the dashboard because it contains not all the metrics which are important. So I add some of those which I think are key, and we explain in the book why these are key. So just to spare a ton of detail, I will skip that, and I will cover only what's important. So this is the dashboard that shows the graph that shows how much time was needed to push one change to the workloads. So here, as we see, because we just created 200 resources, the P99 was 500 milliseconds, so 498 to be exact. So meaning that 99.9% of requests are faster than 498 milliseconds, which is good. It's not bad. So let's see how we can ignore events. Now, in the new namespace, we have one workload called Echo. What we can do is we can delete this. We will see that this generates pushes to the data plane. So in this graph, we see how many pushes are going to the data plane. So here we see some of those. And let's wait a little until we see all of those, but we see that the pod is already getting deleted. So I will interrupt this. Now, what we can do is we can configure the Istio installation to ignore this namespace, because this could be a namespace where we have a lot of pods being created, deleted, a lot of services. So if it's just noise for the other services, so basically the service mesh is not interested in all of this information, we can configure the service mesh to ignore those changes. And this is how we do it. We can specify in the installation the discovery selectors, but we are using a not-in. So basically we select everything that doesn't have the Istio exclude set to true. All the namespaces that don't have Istio exclude set to true. So with that, let's update the Istio installation with the configuration that we just saw. So So the installation is updated. Now what we can do is, so after the installation is updated, some changes might be propagated to the other workloads, such as removing this endpoint. So now I will remove the Istio injection, and after that I will set the Istio exclude to true for this namespace. So because I set this to be excluded, now IstioD will see that, hey, these endpoints that we sent earlier and this configuration that we sent earlier for the echo service is not needed anymore. And if we print all the clusters for the catalog service and search for this echo service, we will see that it's not present anymore. So there is a ton of other services. Let's print those out. So as we see, all the 200 resources that we created just to increase the load, all are there, but not the echo service because we are excluding that one. Now, after doing that, let's just delete the pod. We will see that it will be way less changes that are being pushed. There's just this information that this endpoint is being processed, that a new IP is starting up, but there are no changes being pushed to the workloads. So with that, we are ready to, let's stop this once more. So we see the difference. So what we will do next is let's remove this label. And now after removing this label, let's see that this endpoint is propagated. So that was fast. So now if we check this out, we will see that we have one endpoint for the echo service. This is in this namespace. So by labeling namespaces with the Istio exclusion label or any label that we specify, we can select namespaces and just ignore all of those events that are happening in these namespaces. So let's increase this timer a little further. Let's go to 10 minutes. So this was when it was not optimized, and we can compare the optimizations later on. So let's go to the next part. So ignoring events, that's the first thing. The other thing is we have one performance test which generates some traffic and then queries all the metrics to make sure if the performance was improved or degraded. So let's execute the performance test that does 10 repetitions with a delay of 1.5 seconds in between. And then this is the Prometheus URL where we query the metrics and the gateway that I port forward to my local environment. So now executing this, we see the first set of resources, a gateway, a Kubernetes service, and a virtual service are created. And we do that 10 times. And without any optimization, this is happening in a namespace which is not excluded. So this is a namespace for which all the events will be created. So, and we see there are a ton of pilot push requests. And if you see as well the performance, it is going up to, what's this? It is 900 milliseconds, so it's almost 1 second. So that's quite a lot. Good. And the reason why it's so much is that there is already a lot of information that needs to be propagated. So let's query and just see all the configuration that is sent to one service proxy. So in the Istio in action namespace, I am executing a request that takes the config dump from the Istio proxy and stores it into this file on my local computer. So because we just want to check what is the size. So now we can query the size, and it is 1.7 megabytes. So every change will trigger a 1.7 megabyte endpoint configuration to be generated and to be pushed to all the workloads. So there are some changes which are faster. For example, endpoints are using the incremental XDS approach, which is sending only the delta. So the server and the client are in communication. They see only what's the difference from the previous state and send only that part. But this is implemented only for endpoints, not for services, clusters, listeners, etc. So meaning that most of the changes, besides one endpoint becoming healthy and becoming not healthy and healthy or being rescheduled, and so all the other changes really exhaust the control plane that has to push that amount of configuration. So what we can do is we can define a sidecar resource that specifies the egress traffic of one service. So currently what we are doing here is we are creating a sidecar resource in the default, in the Istio system namespace with the name default. And this applies to all workloads within the cluster. In such a way, we are configuring all the workloads to route traffic only to the Istio system namespace and to the Prometheus namespace. Everything else is not configured, meaning that all these extra configuration of all the other services, those are not being sent to the workloads. If a team needs egress traffic to more services, they would have to overwrite the sidecar configuration, which is the default, which another sidecar which is more specific and meets their criteria. This is quite good as a default because it pushes all the teams to decide what is the egress traffic for their services. And it improves the performance. So let's go here. Let's apply this sidecar resource. Now, with the sidecar resource, IstioD will see that all of these services contain way more information and configuration that they need. For that reason, it is going to generate new configuration which doesn't have all the extra details and send it over to the workloads. So as we see, the performance is way better. So now everything is faster than 99.9 milliseconds, which is a very good performance. So let's execute this and get the updated config done. And now we can see that this reduced the traffic from 1.7 megabyte to 516 kilobyte. And understandably, the improvement will be even better in larger clusters. One more thing that we can check is that previously, when we executed the performance test, we had 640 pushes, and it took it had a latency of 0.49 seconds, so 490 milliseconds. So let's test this again. Now we will make another performance test, and we will see how the sidecar improved this. So basically just specifying the egress of one workload. So just to reiterate, why is this important? It is important because now IstioD can discern when do you want to send a configuration to a workload. So now the performance test is about to complete, and we see that it needed only 90 pushes for 0.10 milliseconds. Yes, Lynn?
That's a great improvement. While we were waiting for the script, I was going to ask you about that script, the performance script. Is that comes with the book, or is that open source tool other people can leverage?
This comes with a book. So this is in our repository. And it is just like a poor man's performance test, so that it basically just checks the improvement or degradation when you make tweaks. But it is just really for the use case of testing stuff out, not production ready or so.
Yeah, very, very cool. Yeah, this really shows Istio has a lot of thing in its toolbox that you can really tune based on your needs and do testing, you know. And I love how you show this with the dashboard. It's really powerful.
Yep, thank you very much. So I will try to make this quick because it's almost 1 hour. So if we go here at the bottom, what we will see as well is that the request size. So basically in this graph, we see that this was the amount of data that was being sent over previously while we didn't have the sidecar. And now this is the amount of data. So basically this was the maximum, but we see the average is way, way lower than that. It's 0.378 bytes. So that's extremely fast. And what's next? So let's check this board with that done. What we can
actually, Renar, I think we're up against the time. Let's there's definitely a lot more, and check out the book.
Yeah, definitely check out the book. There's one question before I let you guys go. I'd like to quickly answer this question for Christian, the other Christian. Does the book handles Liveless or Redis Probe when we migrate our application to Istio?
Yeah. Before we answer that, Renar, can you go to the last slide there just so we can share? There's a we worked with the publisher to get a discount code for the for the book if people are interested. SoloIO41 is the discount code. Right. So the question is around migration and liveness probes and readiness probe, and we do cover that. We cover it in various. There's not like one chapter, one section. I would say it's covered throughout. You'll see a discussion around this on, in the Phantom workload section, in the VM section, and generally in understanding the behavior of Istio lifecycle and that kind of stuff. So it's throughout, I would say, the book.
That's awesome. Well, I hope this gives you guys a good insight of the value the book can bring to you. So I want to take a minute to thank Christian and Reno for speaking here at the live stream, and especially Reno for your excellent demo, very engaging. How do folks reach out to you if they have any questions?
Reno, maybe go to the first slide.
Yep. So
definitely on social media, available anytime. And then on any of the Istio Slack, Solo Slack, CNCF, Kubernetes Slack, you can find us in there as well.
That's awesome. And I hope you guys find this episode interesting. If you do think it's interesting, please comment and like and subscribe to our channel so you don't miss any of our future episodes. Next week, we will come back on Tuesday, talk about accelerate service mesh adoption with eBPF and Murbridge. Thank you so much for watching, and thank you again, Christian and Reno. Bye now.
Thank you, Lynn, for hosting and having us. Yep. Thanks, everyone.
Thanks, Lynn.
Thanks.
Thanks all.